For lesson 8, we're going to talk about quadratic functions in vertex form, which have a little bit to do with completing the square that we learned in our last unit. So describe the transformation applied to the graph of y equals x squared that produces the graphs of the following functions and state the vertex. So if we looked at y equals x squared, that would give us a vertex of 0, 0. So if we look here, what's happening? Well, x plus 3 in parentheses. So plus inside tells us we're moving to the left 3. And minus 4 outside means we're moving down 4. So from the origin, we went to the left 3 and down 4. What point would we get to? Well, going to the left is really negative 3. And then going down is really negative 4. So what point will we be at? Negative 3, negative 4. So that would be our new vertex. So we're going to do the same thing for the other ones. So here we would go right 2 and up 1. So then again, if we had our graph and we went to the right 2 and up 1, what point would we get to? We'd get to the point 2, 1. So what would be our new vertex? 2, 1. And then for our last one, x squared minus 5. So there's nothing in the parentheses. So there is no left or right movement. There's just a minus 5 at the end. So we're just going down 5. So all that would be here would just be a down 5 movement. And what would be the coordinates at that point? Well, we'd stay at 0. And now we'd be at 0, negative 5. Okay. So again, if we know how our parabola is shifted, then we can tell what our new vertex is. So let f be the quadratic function in standard form, such that f of x is ax squared plus bx plus c. So that's how we're used to seeing our parabolas and our quadratic functions. We say that f is in vertex form if it has the structure of f of x equals a, so some number, and then parentheses x minus h. So that's going to be your horizontal movement, and then plus k will be your vertical movement, as it highlights the vertex of the function. All right, so if we're in this form here, then we can tell if we are, or we can tell what the vertex of our parabola is. So consider the function f of x equals x plus 3 squared minus 4. So state the vertex. So again, this is left 3 down 4. So from the origin, if we go left 3 down 4, that gets us to the point negative 3, negative 4. And now how do we answer the maximum or the minimum question? We look in front of the parentheses. Okay? So we look in front of our parentheses. If it is positive, that means it's concave up. So it's our regular U shape, and then in this case, that would be a minimum. If it's negative in front of that parentheses, that means it's concave down, and that would make it a maximum. So if we look in front of our parentheses here, we have a positive number. Therefore, we are going to have a minimum value for this graph. Okay? So again, minimum and maximum just goes by what number and sign is in front of that parentheses, what that a value is. Now, if there's nothing there, it's really just an imaginary 1. Find the x-intercepts of the graph, or of f, I should say. So what that means is we're going to take that equation and we're going to set it equal to 0. Now, we worked on solving these in the last unit, but we may have forgotten. So if we take a look, the first thing we're going to do is we're going to add that 4 to both sides. We get x plus 3 squared equals 4. Then once you have the parenthesis by itself, you will square root both sides. When you square root a parenthesis, you just get what is underneath. So you get x plus 3 equals, and then the square root of 4 is plus or minus 2. Remember, you need both the positives and the negatives when you are solving. So we'll subtract 3 on both sides. Now remember, because of that plus minus, we can't just do 2 minus 3. We take the number we have that we moved over, so in this case, negative 3, plus or minus 2. So now we're going to split this here. We're going to do negative 3 plus 2, and we're going to do negative 3 minus 2. So negative 3 plus 2 is negative 1, and negative 3 minus 2 is negative 5, and those right there are our two x-intercepts. Okay, so again, to find our x-intercepts, we're going to take our equation, and we're going to set it equal to 0. So if we want to sketch this graph, what do we know about it? Well, we know a couple things here. We know it is concave up. All right, so we know it's going to be a U shape. We know we have zeros at x equals negative 1 and x equals negative 5. So we can put those points in, about estimate where they are. So there would be negative 1 and negative 5. And then we have a vertex of negative 3, negative 4. So negative 3, negative 4. All right, so we know we have those 3 points, and we know our parabola is concave up. So that means our parabola is going to look something along the lines of that. Okay, so that right there is going to be the sketch of our graph. And I'm actually just going to put those special points in a different color here just so we can see them a little bit better. All right, so if you have your zeros and you have your vertex, you can sketch what a graph is going to look like. Now we have our last 2 questions here on the bottom. We're going to state the range of this function. So remember, range is smallest y to biggest y. All right, so the smallest y value anywhere here is going to be that negative 4, and that's going to get a bracket because it's included. All right, now because this graph has arrows pointing up, it means it goes all the way up to infinity, and infinity always gets a parenthesis. Okay, so our range here is square bracket negative 4, that's the smallest y, comma infinity because it goes up forever, parenthesis, that's our biggest y. And then our axis of symmetry, remember, is the average of our zeros. So our zeros were negative 1 plus negative 5, and we're going to divide that by 2. So negative 1 plus negative 5 is negative 6. Negative 6 divided by 2 is negative 3. Now, this is a little bit of a mistake that a lot of people were making on last week's assignment, or 2 weeks ago assignment, I should say, is that axis of symmetry is a line. It's x equals that number. You're not allowed to just write that the axis of symmetry is negative 3. It's always x equals negative 3. Now, because we knew our vertex, we also could have just taken the x part of our vertex, all right, which was also that negative 3. So 2 different ways to look at it. You could look at the average of the zeros, or you could look at the x part of the vertex if that information is available to you. So you can see how once we're in vertex form here, we can answer a lot of questions based upon just doing a little bit of solving. Number 2 is basically the same thing. Now they've changed it up a little bit in the solving here. So what I'd like you to do is try this one on your own. It seems a little bit different because of the negative 2. Now the negative 2 only really affects our solving piece. Most everything else goes off our same rules. So see if you can try this before you sit down and watch the rest of the video. All right, so as you go, this is in vertex form. So the vertex here, well, we're going right 5 and up 8. So that's going to give us a vertex of positive 5 and positive 8 on our graph, because if you go right 5 and up 8 from the origin, you end up at the point 5, 8. And is this a maximum or a minimum? And it's going to be a maximum point based on the same rules that we had last time, right? There's a negative in front of our parentheses, all right? So if we just look back at our previous one here, remember, positive means it's concave up and it's a minimum. If it's a negative out in front, that means it's concave down and it's a maximum. So because of that negative 2 here that's out in front, that's going to make it concave down, and that's going to give us a maximum. So now we want to find the x-intercepts of f. So again, we do that by setting this equal to 0. So same process as before, we'll subtract that 8 over to the other side. So the only difference is here, now we have to address the -2. So we're going to divide both sides by that -2. You can't distribute. All right, that exponent blocks you from being able to distribute that -2 into the parentheses. So be careful here. -8 divided by -2 is +4. Two negatives cancel out. We'll square root both sides. We get x minus 5 equals plus or minus 2. We'll add the 5 to both sides. And we get, I'm just going to bring this over here a little bit. We get x equals 5 plus or minus 2. So we're going to split that here. We have 5 plus 2, which is 7. And we have 5 minus 2, which is 3. And those are going to be our two x intercepts. Okay, x is going to equal 7 and x is going to equal 3 are the two x-intercepts. So now if we want to sketch a graph here, okay, well, what do we know about this, right? We know we have a vertex at 5, 8. So if we approximate our vertex at 5, 8, we have our zeros at x equals 7 and x equals 3. So if we approximate those, we look like that. And then our last piece of information that we know is that we are concave down. So if we go to sketch our graph here, our graph is going to look something like that. All right, and I'll just re-highlight these points again. So the greens are vertex, and the blue are going to be our two zeros. All right, so again, not an exact graph, just a sketch, but just when you have the vertex and your zeros, then you know you can solve for your, or you can at least sketch a graph for your picture. So if we want to state the range, okay, now in this case, our arrows are pointing down. So the smallest y value in this case is going to be -infinity, all right, because those arrows are pointing all the way down. The highest y value here is going to be 8, and that's going to get a square bracket. So we're going to be open parentheses, -infinity, because the arrows point down, comma 8, close bracket, because 8 is included in this piece. And then if we want to state the axis of symmetry, I'm going to take it real easy, as our vertex is 5, 8. So last time I used the average of the zeros. This time I'm just going to use the fact that I know what the vertex is, and I know my axis of symmetry is the x part of my vertex. Okay, so that's, again, another way to do a lot of solving based on one of our quadratics in vertex form. Number 3 says, write an equation of a quadratic function with a vertex of 2, -4. How many quadratic functions exist? Well, if we need a vertex of 2, -4, there's that point. Well, how do you get there from the origin? Well, what do you have to do? You have to go right 2, and you have to go down 4. So if we think about our quadratic equations, we are going to be f of x equals, now if we need to go right 2, that means our parenthesis has to be minus. So we're x minus 2 squared. And then if we need to go down 4, we will be minus 4. Okay, so the x minus 2 in the parentheses tells us that we went right 2. The minus 4 afterwards tells us that we went down 4. And how many quadratic functions could exist with this vertex? The answer is infinite. Okay, you can have an infinite number of equations because you can put any number in front of your parentheses. Okay, so for example, and let me just block off the second part of the question here. So for example, f of x could equal -2 x minus 2 squared minus 4. And that would have the right vertex. F of x could equal 1/3 x minus 2 squared minus 4, and that would have the right vertex. So it doesn't matter what number you put out in front, it's not going to change what the vertex is. So you have an infinite number of options because you can put whatever number you want out in front. Okay. Now, what if you knew the function had to pass through the point 0, negative 16? Well, once you know a second point that it goes through, then you only have one option. Okay. Now, here's how you figure out what that option is. You have a 0, or 0 is x, and negative 16 is y. So negative 16 equals, now we're trying to figure out what that number is out in front. We'll call it a, okay, because that's the letter that's typically used out in front. What's going in for 0? Excuse me, what's going in for x? 0, so 0 minus 2 squared minus 4. Okay, so what we did is we plugged the 0 in for x, we plugged the negative 16 in for y, and then we put that a out in front because we're going to figure out what number do we have to put out in front so it specifically goes through the point 0, negative 16. So if we follow our order of operations here, the first thing we would do is our parentheses. So negative 16 equals a, 0 minus 2 is negative 2 squared minus 4. Next thing would be negative 16 equals a, we do exponents, so negative 2 squared is positive 4 minus 4. The next best thing to do would be to add that 4 at the very end to both sides. So negative 16 plus 4 is negative 12, and I'm going to rewrite a times 4 to be 4a. We'll divide both sides by 4, and we get negative 3 for a. So then our only option that goes through that point would be f of x equals negative 3 times x minus 2 squared minus 4. Okay, so again, if we know a specific point that it goes through, then we can plug in our x and y to solve for exactly what number goes in front. And our last one, a student throws a bag of chips to her friend. Unfortunately, her friend does not catch the bag of chips and it hits the ground. The distance from the ground height for the bag of the chips is modeled by the function h of t equals negative 16 times t minus 1 squared plus 20, where h is the height, all right, which is the distance from the ground in feet, and t is the number of seconds that the chips are in the air. So state the vertex and interpret its meaning in the context of this problem. So remember, our vertex here is going to be right 1 and up 20. Okay, the t minus 1 in parentheses tells us we go right 1. The plus 20 tells us we go up 20. All right, that negative 16 out in front does not help us too much right this second. So what does that tell us our vertex is? Our vertex is 1, 20. All right. Now, if you think about it, when you throw chips in the air, or you throw something in the air, it has that concave down sort of fashion. You throw it up, it hits a maximum height, and then it comes back down. So our vertex here is going to be a maximum point. So what does this 1, 20 really mean for this problem? That means after 1 second, the chips reached their maximum height of 20 feet. Okay, so that first number, okay, which normally is our x, in this case they replaced the x with the t, is our time. So it took 1 second for the chips to reach their maximum height. And what was that maximum height? Well, that's going to be the y part, which is going to be, in this case, 20. How many seconds to the nearest tenth after the bag was thrown did it hit the ground? Now, when we try to figure out when things hit the ground, those are always our zeros, okay? So if we want to solve for our zeros here, we have to take our equation. So negative 16, parentheses, t minus 1 squared plus 20 equals 0, okay? So we're going to subtract our 20 on both sides. Negative 16, t minus 1 squared equals negative 20. We'll divide both sides by negative 16. Now, this doesn't divide perfectly, but it might be a good idea to put it into your calculator here and see if we can simplify it a little bit. So you can keep it as 1.25, that's fine. It said rounding to the nearest tenth anyway. So t minus 1 squared equals 1.25. Square root both sides. T minus 1 equals, now let's see what the square root of 1.25 gives us. So that's pretty awful. So here's what I'm going to suggest you do. I'm going to suggest you just leave that as plus or minus square root 1.25. Okay? We'll add the 1 over to the other side, and I'm just going to bring this up here. So we get t equals 1 plus the square root of 1.25 and 1 minus the square root of 1.25. All right? So now because it wants us to round, we're going to split that. So we're going to do 1 plus, and we're going to do 1 minus that square root. All right, so let's take a look here. 1 plus the square root of 1.25 gives us 2.118, and I believe it wanted us to round to the nearest tenth. So 2.11, so that rounds to 2.1. And then let's try 1 minus the square root of 1.25. Now that gives us negative 0.1. Now, think about what this question is asking. These represent times. Can you have a time of negative 0.1 seconds? No. So what's our answer have to be? It has to be 2.1. Okay, that's the only option that makes sense for when this bag would hit the ground. Okay, because obviously it cannot hit the ground after negative 0.1 seconds. So then we have to use our other zero, which is our 2.1. And for the last part here, determine how long to the nearest tenth of a second the chip's height was higher than 10 feet. So if we wanted to find out when it hit the ground, if that was when we set it equal to 0, because it was 0 feet off the ground, if we want to figure out when it's higher than 10 feet, we're going to take that same equation and we're going to set it equal to 10. So negative 16, parentheses, t minus 1 squared plus 20 equals 10. Okay, so now we'll subtract our 20 on both sides. We get negative 16, t minus 1 squared equals negative 10. Divide both sides by negative 16. We get t minus 1 squared equals, all right, and we'll get this simplified in here, so negative 10 divided by negative 16 gives us 0.625. We're going to end up rounding, so you could leave it there as well. Square root, okay? My suggestion is do the same exact thing we just did, so plus or minus square root 0.625, add the 1 to both sides, and we have 1 plus or minus square root 0.625. So now we'll do the same thing, we'll split it. We'll go 1 plus that square root, and we go 1 minus that square root, all right? So as we go into our calculator here, 1 plus square root 0.625, you get 1.79, and it's said to the nearest tenth, so 1.8. And then we'll do 1 minus square root 0.625, and that's going to give us 0.2. So both of these numbers are positive, so nothing is getting rejected, but we're going to use this basically as an interval. The chips were higher than 10 feet from 0.2 seconds to 1.8 seconds. Okay, so we're going to use that as this is going to be the first time it hits 10 feet, then it's going to go above that, and on its way back down, this will be how long it takes to hit that 10 feet again on the way back down. So we're going to use those as an interval for 0.2 seconds to 1.8 seconds for when our chips were higher than 10 feet.